Good morning, students. Have you finished your prayer? Thank you. நான் ஒரு நல்லாசிரியர். நான் உங்களுக்கு தாயாகவும் தந்தையாகவும் இருந்து முறையாக அன்போடு கல்வியை போதிப்பேன். நான் ஒரு நல்லாசிரியர். நான் உங்களுக்கு தாயாகவும் தந்தையாகவும் இருந்து முறையாக அன்போடு கல்வியை போதிப்பேன். நான் ஒரு நல்லாசிரியர். நான் உங்களுக்கு தாயாகவும் தந்தையாகவும் இருந்து முறையாக அன்போடு கல்வியை போதிப்பேன். Okay, students, take your social science book. Come to page number 160. Today we will move to the next topic, geomorphic process. So what do you mean by geomorphic process? So it is nothing but the process that acts on the earth, so which shapes the earth, so which shapes the surface of the earth was called as geomorphic process. So the process which change the shape of the or the surface of the earth, that was called as geomorphic process. Okay, so let us move into the lesson. So before entering to the lesson, so let us recall what we have discussed in our previous class. In our previous class, we discussed about the different types of rocks. So first is the definition for rocks and the different types of rocks. So what are the different types of rocks classified based on their formation? Igneous, metamorphic and sedimentary. So we saw detailedly about those rocks. Okay, so what do you mean by igneous, what do you mean by sedimentary, then what do you mean by metamorphosis, then some examples for those rocks. Then finally we saw about the rock cycle. Okay, so in today's class we will see detailedly about the geomorphic process. So the process which results in the formation of various natural surfaces on earth. So in earth surface you can find a lot of differentiation. Okay, so some areas you can hilly areas was seen, in some areas plains, so some areas values are seen now. So how it was formed, so why, the reason behind it. So what was the reason behind it for the formation of these different natural surfaces. Okay, so we saw about it detailing. Okay, so what was the reason behind it, what was the process behind it, so we saw about it. So geomorphic process, so the forces that act from earth interior towards the earth surface are called as internal process or endogenetic process. Okay, so the process, the geomorphic process is classified into two. One is called as internal process and another one is called as external process. So internal process means the forces that act from earth interior, so that is these forces act from core, mantle and move towards crust. Okay, so it act from interior of the earth and shapes the earth's surface. Okay, so these forces build the landscape and create a topographic relief, that is it act from the interior and change the surface of the earth. Okay, so it change the surface of the earth. Another force was called as external process, so the forces that act on the surface of the earth, so due to natural agents. Okay, so which forces act on the surface of the earth means it was natural forces. Okay, so natural forces like running water, glacier, wind, waves, etc. are called as external process. Okay, so the forces that act on the surface of the earth due to natural agents like running water, glacier, wind, waves, etc. are called external process. So these external process tear the landscape down into relatively low elevated plains and shapes the landform created by endogenetic process. Okay, so if the endogenetic process pushes the land upwards, the external process, the exogenetic process, it form a low elevated plain. So exogenetic process form a low elevated plain. So it is the main difference. So the internal process act from interior of the earth and pushes the earth slightly upward. The external forces, so it washed away or it tear the landscape, and form plains. Okay, so these are the main difference between the external process and internal process. Internal process, so the internal process generate heat and eject materials from deep below the earth's crust. So internal radioactivity is the principal source of power for this purposes. Okay, that is internal process. So how the internal process take place? So the interior part of earth temperature is very high when compared to the exterior part. So that is, if you reach the core of the earth, the temperature is more than 6000 degrees Celsius. Okay, so these heat waves, so these heat waves pushes up the crust. So these heat waves, so which is in the interior part of the earth, ejects materials from the deep below the earth's crust. So this internal radioactivity is the principal source of power for this purpose. So for internal process, so the internal radioactivity is the main source. So for external purposes, the natural agents like water, glacier, wind, etc. act as a source of power. Likewise, in internal process, internal radioactivity is the principal source of power for this purpose. Then plate tectonics. So the lithosphere, so that is the surface which we stand, is divided into a number of huge slab of rocks called tectonic plates. So the lithosphere, so which is stand, that is the crust, is divided into a number of huge slab of rocks called as tectonic plates. So these tectonic plates are divided into major and minor plates. So in the next picture you can see. So this huge slab of rocks called as tectonic plates was divided into a number of major and minor plates. So these plates floats independently over the mantle. So these plates, so that is these major and minor plates, so float over the mantle. So the three layers of earth, what are they? Crust, mantle, core. So these tectonic plates, so floats over the mantle. So tectonic plate means so nothing but the crust. So the collision of these plates produce mountain ranges and other irregular surface features both on land and also in the ocean floor. So these plates, so independently move. Independently, so float over the mantle. So whenever these plates collide with each other means it produces some irregular surfaces on the earth, both in land and in the ocean floor. So this phenomenon is called as plate tectonics. So this phenomenon is called as plate tectonics. So plate tectonic means so nothing but the collision of the plates that produce mountain ranges or other irregular surfaces means it was called as plate tectonics. So what was the reason for the movement of this plate tectonics? It is due to the thermal energy from the mantle. So the mantle so contains the molten rock. So that is it have molten rock, so which have a huge mass of heat. So it produces a huge mass of heat energy, that is thermal energy. So that pushes the crust, that pushes the plate tectonics to float. So because, and also now we have a better understanding about the plate movement and its relation to earthquakes and volcanic activities. So now we can understand. So from this we can understand. So because of the plate movements only, the earthquake and volcanic eruptions occurs. So let us see the types of plate boundaries. So this picture shows the different types of plate tectonics. So the earth was divided into several plates, so like this only. So there are large plates and also small plates. So few are small plates, so like Philippine plate, Arabian plate, Indian plate, Nazca plate, Caribbean plate, etc. These are very small plates. But if you take African plate, Eurasian plate, Australian plate, Pacific plate, so they are some big size plate. So they are large plates. So types of plate boundaries. So first, convergent boundary. So here the plate moves towards each other and sometimes a plate sinks under another. So in this type of plate boundary, the plates move towards each other. So moves in the each other and sometimes a plate sinks under another. Sometimes in this process, so one plate goes down and another plate comes up. So the location where the sinking of a plate occurs is called subduction zone. Example, fold mountains, Himalayas. So during this process, so one plate goes down and another place moves up. So that is called a subduction zone. So due to this it formed fold mountains, so like Himalayas. So you can see in these pictures also. So one continental plate is moving down and another continental plate is moving upward. So that result in the formation of mountain range and also plateaus. So high plateaus. So divergent boundary. So in this process, so the plates pull away from each other so that the magma pushes up from the mantle. So in this plates, so in this boundary, the plates pull away from each other. So that is the plates move away from each other. So already we saw, so these plates float over mantle. So the mantle contains the magma. So whenever there is a gap means the magma so come out. So due to high pressure and heat in the interior of the earth. So this type of boundary you can found in the Atlantic ridge. So it is in Atlantic Ocean region. Okay, so you can find volcano eruption in this region in enormous amount. Okay, so since the plate so move away from each other, so the magma so which is in the interior of the earth, that is in the mantle, so eject out, so try to comes out. Okay, so that is called as divergent boundary. It was seen in mid Atlantic ridge. So conservative transfer boundary, so here the plates slide horizontally past each other. So the best example for this is San Andreas fault. Yeah, so San Andreas fault, you can see this. Okay, so you see in this picture, so one plate is both plates are moving in an opposite direction. Yeah, so opposite direction horizontally. Yeah, so conservative plate is nothing but so the plates move horizontally. So example for this is so San Andreas fault. So movement of continental plates. So we saw the plates are moving. Yeah, so the tectonic plates, so which floats over mantle. Yeah, so was in constant motion. Yeah. So what is the reason for the movement of these continental plates? So it is nothing but the pressure. So the thermal energy so comes out from the earth. Yeah. So due to the lateral compressional forces. So what I mean by lateral compression force? So it is nothing but a physical force, so which moves, so which presses the object in its inward direction and make it compact. So lateral compression force is nothing but so some force, some physical forces act on the surface internally. You know, so some physical forces act on the surfaces internally so that it get compacted, that is it get closely packed. Yeah. So and the because of these lateral compressional forces, the plates are forced to move upward and downward. You know, so due to the compression force, so due to the compression force, so which pushes the plates, so the plates are forced to move upward and downward. So this is called as folding. So mountains formed by folding are called fold mountains. So the process of fold creates lofty mountain ranges. So that is highest mountain ranges such as the Himalayas and the Alps. Yeah, so because of the lateral compression forces, so the plates are forced to move upward and downward, which is called as folding. So due to this folding process, so lofty mountain ranges such as the mountains like Himalayas and Alps were created. So the plate tectonics, so that is the plates are in constant motion, already we saw. So what was the speed? It is very speed? No, so it is very slow. Yeah, so according to plate tectonics, the plates are in constant motion with an average rate of few centimeters per year. Yeah, so just to move a few centimeters only. So for a year it just move a few centimeter or a few millimeter only. So the movement might seem slow, so you can't feel this movement. So do you feel the movement of plates? No. Yes, because it is very slow, but over millions of years the plates and the continents riding on them moves a long way. Yeah. So since it is very slow, but it takes it was going on millions of years, so you can saw a lot of change in the tectonic plates. Okay, so for example, 250 million years ago, the Indian plate was a part of the Gondwana land, which comprised of modern Africa, Australia, Antarctica and South America. Yeah, so do you know, initially the earth was consist of only one plate. Yes, later the plate is divided into two. One is Eurasian plate, another one is called as Gondwana land. Yeah. So before 250 million years ago, Indian plate was a part of Gondwana land. So the Gondwana land comprised of modern Africa, Australia, Antarctica and South America. Okay. So before 140 million years ago, the Indian plate broke away from the Gondwana land and moved towards north. Yeah, so before 140 million years ago, so the Indian plate, so which was a part of African plate, that is Gondwana land, so broke away from the Gondwana land and moved towards north, that is towards Eurasian plate. Yeah. So this Indian plate so collided with the Eurasian plate along the boundary between India and Nepal, so and formed the orogenic belt that created the Tibetan plateau and the mighty Himalayan mountains. So this movement of plate Indian plate, so which collided with the Eurasian plate, that is Asian plate, so result in the formation of Himalayan mountains. So this is an example for which type of plate boundary? Convergent, divergent, or conservative? Convergent. So because in this process, so the Indian plate collided with the Asian plate, and it moves up, so that's why it was called as convergent boundary. So this is just an overview of plate boundary, so plate movement and the resultant landform. You can find volcano eruption, so some ridges, some mountain ranges, and the process behind it. So that is the thermal energy, so which pushes the tectonic plates to move. So the thermal energy, so from the interior of the earth is the main reason for the movement of plates. So the heat waves that is produced from the interior of the earth, so pushes the plates, so that the plates float over the earth surface and are moving each other, so moving in a particular direction. So that was the reason for volcano eruption, earthquake, different landforms. So it is nothing but earth internal process. So in this picture you can see different type of boundary, plate boundary, and also the process behind it, and also the different type of land formation. So it is just a simple picture. Okay students, so this topic over. So geomorphic process get over. In tomorrow's class we will see about the earthquake and also tsunami and volcano. So because of the plate movements, so these three processes occur: earthquake, tsunami, and volcanoes. So how it occurs, we will see detailedly in tomorrow's class. So complete your homework. Any doubt, so contact me. Thank you. So have a nice day.
நாம் வாழும் பூமி ஒரு அற்புதமான கோள் ஆகும். புவிக்குள்ளேயும் புவிக்கு வெளியிலும் எண்ணற்ற மாற்றங்கள் நாளுக்கு நாள் நிகழ்ந்த வண்ணம் உள்ளன. மேலும் புவியின் மேல் நிகழும் மாற்றங்களை நாம் நேரிடையாக காண முடிகிறது. ஆனால் புவியின் உள்ளே நிகழும் மாற்றங்களையோ நம்மால் காண இயலாது. புவியின் உட்பகுதியில் நிகழும் மாற்றங்களை நாம் அகச்செயல் என்கிறோம். இதற்கான காரணிகள்தான் எவை? வெப்பநிலை, அழுத்தம், அடர்த்தி மற்றும் நில அதிர்வு அலைகள் ஆகும். இவற்றுள் வெப்பநிலையை பார்ப்போம். புவிக்குள்ளே ஏற்படுகின்ற எரிமலை சீற்றம் மற்றும் வெப்ப நீரூற்றுக்களின் வாயிலாக வெப்பநிலை அதிகரிக்கிறது. ஒவ்வொரு 32 மீட்டர் கீழே செல்ல செல்ல 1 டிகிரி செல்சியஸ் வெப்பநிலை உயர்கிறது. மேலும் இவற்றோடு இணைந்து மாக்மா தோற்றம், மாக்மா அதிகரிப்பு, வெப்ப ஓட்டம் போன்றவையும் காரணமாக அமைகின்றன. இவையே நம் புவியின் உட்பகுதியின் வெப்ப கதிர்வீச்சுக்கு காரணமாக அமைகிறது. அடுத்து அழுத்தம். இது புவியின் வெளிப்புற அடுக்கில் இருந்து உட்புறமாக தாக்குகிறது. எனவே அங்கு பாறைகள் திரவ நிலைக்கு செல்வதை தடுத்து திடநிலையில் வைக்கிறது. மூன்றாவதாக அடர்த்தி. புவியின் உட்பகுதியில் உள்ள பாறைகளின் அடர்த்தி மெதுவாக மையப்பகுதியை நோக்கி அதிகரிக்கிறது. புவியின் மையப்பகுதியில் நிக்கலும் இரும்பும் சேர்ந்த கலவை உள்ளதால் அடர்த்தியின் நிலை மாறுபட்டு காணப்படுகிறது. இறுதியாக நில அதிர்வு அலைகள் முதன்மை அலைகளாகவும் இரண்டாம் நிலை அலைகளாகவும் மற்றும் நீண்ட அலைகளாகவும் செயல்பட்டு புவியின் உள்ளே வெப்பநிலை மாற்றத்திற்கு காரணமாக அமைகிறது. புவித்தட்டுகள் சுமார் 300 மில்லியன் வருடங்களுக்கு முன்பு எல்லா கண்டங்களும் ஒருங்கிணைந்து காணப்பட்டது. இவ்வகை அமைப்புகளை பாஞ்சியா என்கிறோம். அனைத்து நீர்நிலைகளும் ஒருங்கிணைந்து காணப்பட்ட அமைப்பு பாந்தலாசா என்பர். புவிக்கு மேல் பாஞ்சியாவும் பாந்தலாசாவும் காணப்பட்டாலும் புவிக்குள்ளே நாளுக்கு நாள் எண்ணற்ற மாற்றங்கள் நிகழ்ந்த வண்ணம் உள்ளது. புவியானது வருடத்திற்கு சில சென்டிமீட்டர் அளவுக்கு மேல் நகர்கிறது. நகர்வு சிறியதாக இருந்தாலும் வருட நோக்கில் பார்த்தால் மிக பெரியதாக தோன்றும். இவ்வாறு புவிக்குள்ளே நிகழும் நகர்வினை புவித்தட்டு நகர்வு என்கிறோம். புவித்தட்டுகளின் நகர்வினால் பாறைகளின் மீது அழுத்தம் இறுக்கம் ஏற்பட்டு அவை விரிவடைந்து அதனால் பாறைகளில் விரிசல்கள் ஏற்படுகின்றது. இப்பாறை விரிசல்கள் பிளவுகள் என்று கூறுகிறோம். கிழக்கு ஆப்பிரிக்காவில் உள்ள பிளவு பள்ளத்தாக்கு இதற்கு சிறந்த உதாரணமாகும். புவித்தட்டுகள் நகர்கின்ற போது அவை கண்டப்பகுதியில் தனியாகவோ கடல் பகுதியில் தனியாகவோ அல்லது இரண்டு பகுதியிலும் இணைந்தும் உள்ளிருந்து மாற்றத்தை ஏற்படுத்துகிறது. அவை இணைதல், விலகுதல் மற்றும் பக்க நகர்வு செயல்பாடாகும். இரண்டு தட்டுகள் ஒன்றை நோக்கி ஒன்று நகர்வதை இணைதல் என்கிறோம். சில தட்டுகள் ஒன்றை நோக்கி ஒன்று நகர்கின்ற போது திடீரென்று விலகிச் சென்று விடுவதை பக்க நகர்வு என்கிறோம். சில தட்டுகள் எதிர் எதிர் திசையில் நகர்ந்து மாற்றத்தை உருவாக்குகிறது. இதனை விலகுதல் என்கிறோம். புவியின் நகர்வானது பாறை கோளத்திற்கு கீழே நடைபெறுகிறது. எனவே பாறை கோளத்தின் அடிப்படையில் புவித்தட்டுகளை முதன்மை தட்டுகள் என்றும் சிறிய புவித்தட்டுகள் என்றும் அழைக்கின்றோம். புவியின் முதன்மை தட்டுக்கள் 6 வகையாகவும் சிறிய தட்டுக்கள் 20 வகையாகவும் காணப்பட்டது. முதன்மையான தட்டுகள் என்பது யுரேசியன் தட்டு, இந்திய ஆஸ்திரேலியன் தட்டு, அமெரிக்கா தட்டு, பசிபிக் தட்டு, ஆப்பிரிக்கன் தட்டு மற்றும் அண்டார்டிகன் தட்டு ஆகியவையாகும். சிறிய புவித்தட்டுகளுக்கு உதாரணமாக சோமாலி தட்டு, பிலிப்பைன் கடல் தட்டு, அரேபியன் தட்டு, கரிபியன் தட்டு, பர்மா தட்டு ஆகும். சுமார் 250 மில்லியன் வருடத்திற்கு முன்பு கோண்டுவானா நிலப்பகுதியில் ஒரு பகுதியாக இருந்த இந்திய புவித்தட்டு தற்போதைய ஆப்பிரிக்கா, ஆஸ்திரேலியா, அண்டார்டிகா மற்றும் தென் அமெரிக்காவுடன் இணைந்து காணப்படுகிறது. நமது இந்திய தட்டானது 140 மில்லியன் வருடங்களுக்கு முன்பு கோண்டுவானா பகுதியில் இருந்து விடுபட்டு வடக்கு நோக்கி உள்ளது.